Now, when we apply forces to, so far we've just been working with position and velocity and using the velocity to update the particle's position. By using forces, what we'll be doing is a double layer effect where we'll be using a force to update the velocity as time goes by, and we'll use velocity to update the position. So the most common force that's used inside particles or dynamics of whatever type, of whatever kind, is gravity. You actually have a node called gravity force, and you can usually place it after the pop solver, because this gravity is going to be able to apply, it's going to work with a lot of different solvers, not just the pop solver. So right now, if you hit play, you'll see that we have our particles coming down. Okay, we can control the intensity, but this is the correct value for having a gravity effect. If you don't want them to come down as fast, what you could do is increase the velocity of your particles. So here, when we're generating V, we can set a speed. Let's just go in and make sure that the noise, when it multiplies what we have so far, it never multiplies by 0. Otherwise, we'll have particles that are completely stopped. So let's say 0.1 to 1. And I'm going to go up. And let's say we have a maximum speed of 10 or 20. And you'll see that they project a lot more, a lot further. Bit too much, definitely. Let's hit play. And you get this effect. Okay, next. This is the most common force. It's not necessarily the most interesting, so I'm kind of gonna disable it and actually lower the speed that we have. Let's say 5. And going inside a pop network, let's work with a pop force. Why not? Pop force. So the pop force is the most basic type of force that you can have. You can control the overall vector and direction that we were going to use. Let's say we want to push it up. Let's add a force that's of 1 unit strong on the y-axis, and we should see our particles kind of rising with time. But it's also still kind of boring just by itself. So most forces will have a noise parameter, and this is where things start to get more interesting. Let's I'm going to disable the force direction for now and just work with the amplitude here. So let's start with 1, see what this gives us. I'm going to make it more visible. Let's say an amplitude of 5. Okay, and it immediately starts breaking up our shapes. Now there are some parameters that are pretty familiar, should be pretty familiar, or that have an easy correspondence to the parameters that you usually have on a noise. The swirl size is going to be kind of a frequency of the shape. So the higher this is, let's say 5, it's going to give us variations more like this, okay, that are bigger shapes of noise. So it depends on the effect that you're going for. And this is a good setting for us to be able to see what the other parameters do. So the roughness is the same as you have for the other types of noises. It's going to give you a more bigger contrast and smaller detail on these shapes. So if we set the roughness to 0.8, you'll see it breaks up the shape faster. Okay, it's a bit more extreme as well. Let's say maybe lower the amplitude just a bit. And the size, I'm going to put it to 2. It's still pretty strong. If you wanted to keep the direction that it has initially, the velocity that it, a bit more of the velocity that it has initially, then you really need to kind of lower that. And if you don't want it to break so much, then you would need to make sure that your swirl size is a bit bigger. but you get some interesting shapes. Let me hit play. So this is real time. Another important parameter is the pulse length. So this determines how fast the shape of the noise is changing. If we say that the pulse length is like 10 seconds, then you'll see that the shape is preserved. The noise shape is gonna stay the same for a lot longer. There, you don't see this kind of distortion that's happening here is gonna be happening for a long amount of time. If we, for instance, use a pulse length of 0.2, then it's just chaos. It's always changing. So we can't really, it's just starts dispersing and you can't really see the shape of what's happening. So it's up to you. It depends on the scale of the effect and how fast we want things to break apart. I'm gonna put the amplitude at 0.5. And of course, you can sum up as many, combine all of these. So let's say we wanted the force, but we also wanted the gravity. That's totally fine. Okay, now we have the gravity affecting the particles. So a very common question to have when we start working with particles inside Houdini is how do we kill the particles? That's something that on every system you really need to know. So the easiest way is by establishing a life expectancy, a lifespan of, let's say, 2. I can determine that after frame 48 they just die. Okay, after frame 48 they start dying. This might not be enough. You can create some variation. Let's say 2 or 1 plus 0.5, and that way we don't have them dying all at the same time. There's kind of, okay, so when you have a volume of particles and you have some life rise, you don't have just an abrupt finish of that shape. You have kind of loss of density before it kind of finishes, it ends. But a lot of times this is just not enough. Let me kind of lower the intensity. I know, let's say -5, just so it's not as strong. It's a bit slower falling. Okay, now another way, we can use any criteria to kill particles. So you can, let me put this at 0. You have an operator called pop kill. And this pop kill works with a rule. I think that's the easiest way. We enable the expression, and whenever the expression turns 1, it's gonna kill the particle. So right now it's at 1, so it's killing all of them. If I put this at 0, it doesn't kill any particle. So you can use any condition to define this value. So let's say I want to kill any particle that goes below the ground level. So what I would do is, if the y component of my position is lower than 0, this expression will return 1 and they will be considered dead. Okay. So once they hit the ground, they die. On the next lesson, we'll see how we deal with collisions when working with particles.